Welcome to our video on solving 1 and 2 step equations with POES. There's going to be some language that we introduce to you that's going to be easier when you're presenting these problems. And the first thing we got to discuss is, what does POE stand for? POE is abbreviation for property of equality, and we're going to go ahead and define that as the operation you perform to both sides of the equation to isolate the unknown. Technically, in equations, you have an unknown until you solve for it, and then there's one value that can be plugged in. So it's not necessarily a variable at this point, but we might use the term variable too, which is what a lot of people do. There are four properties of equalities. SPO is subtraction property of equality, APO, MPO, and DPO. And the more you work with this language, the easier it's going to be. For equation solving, our objective is to isolate our variable by working backwards to undo what is currently happening to it. When these get more complicated, just think we're doing reverse order of operations. We're unpackaging things. So what you're going to use in addition to these notes to help you from here on out is the pink sheets, translating verbal phrases. On the reverse of this, there is a lot of tips to help yourself. This is if you're having trouble with CLT, take a look at it. This is good stuff to keep in mind when you're thinking about equations. Equation is just a balancing act. It needs to be equal at all points. So this scale down here is a good visualization of that. So here is a basic example and how we need you to show your work. So the equation is x plus 5 equals 20. You could kind of figure out what the value of x has to be here, but we need you to show your work in this way. So we are isolating the variable by doing what's the opposite of what's happening. What's the opposite of adding 5? Well, subtracting 5. What I do to one side of the equation, I must do to the other. The language for this is SPO. I could say I'm going to SPO 5, and that implies that you're doing it to both sides. So 5 minus 5 creates 0. X plus anything, x plus that identity element of addition, leaves me with x equals 15. In higher mathematics, when we solve equations, we can put our solution in what's called set notation. So we can say that the solution to this problem is 15. And the thing with equations is it's always easy to check your work, and at least you should do that mentally before you move on. So if our solution is 15, if we were to plug 15 in for x, it becomes 15 plus 20. The left side equals the right side. We can check, we've got the solution. So this problem, we have SPO'd 5 and gotten a solution of 15. So here's another one, just so you can get used to the language. You don't have to write the POES down beside it, but if that helps you, you're welcome to it. The next equation is x over 8 is equal to 10. So what is currently happening to x? It's being divided by 8. What's the opposite of dividing by 8? Multiply by 8. So this would be called MPOing 8. So 8 on the top and on the bottom cancels out, creates 1, which is that identity element of multiplication. So we have 1x is equal to 80. So before we say that is our solution, let's go ahead and perform the mental check. Substitute 80 in for x. 80 divided by 8 is 10. 10 is equal to 10. We're good. So the solution to this equation is 80. Right? Equations are also reflexive. I can flip them like this, like you would on a mirror. So when we have instances like this example, 21 equals 3x, it's going to work the same way. You're going to isolate x no matter where it is. So now, what is happening to x? It's being multiplied by 3. So what's the opposite? I'm going to depot 3. What I do to one side, I have to do to the other so that it maintains the balance. So I depot 3. These cancel out. 21 divided by 3 is 7. So my solution is 7. Do the mental check. Substitute 7 in here. 3 times 7 is 21. 21 is 21. We're good. So the solution to this one is 7. You don't have to put your solutions in set notation, but if you want to prepare yourself for higher math, go ahead and do it. If you just want to say 7 is x, or like in this case, x is 15, or in this case, x is 80, that's acceptable at this point. One last example before we do now number 1. If you have an equation like x squared equals 49, we've actually done stuff like this before. What's happening to x? It's being squared. So what's the opposite of squaring? We have square root. What I do to one side, I do to the other. What's the square root of x squared? These two, remember, kind of cancel out. So we got x is equal to the square root of 49, which is 7. So again, set notation if you would like. Otherwise, just be sure to check this mentally. 7 squared is 49. We're good. So now for do now number 1, go ahead and pause this video and try it on your own, and then we will discuss it. For do now number 1, put a big old triangle around it. You're to solve these two equations. A is x minus 1 equals negative 13, and B is 20 is equal to 6x. So now we can discuss these. For the first one, I am going to APO1, create that 0. So x is equal to a negative 13 plus 1, which is a negative 12. Before you box it, let's check it. Negative 12 minus 1 is negative 13. We're good. For B, we have to undo this multiplication, so we're going to depose 6. That cancels out. You have something like this. And we know that we love fractions because our answers can be fractions, and you don't have to worry about long division. You just have to think about, is my fraction simplified? So in this case, I know my answer is not going to be a whole number, so I take my fraction. What did 20 and 6 share? Well, they're both divisible by 2, so that takes it to 10/3 is x. Now we're at a point where it's harder to check mentally, so go ahead and check it by substituting in your solution to where your variable is in the answer, or in the original equation. So when I substitute things, I know they have to be in parentheses. So I'm going to say 6 times, my solution is 10/3. And now, this is another reason why we like the fractions, because we can cross simplify. So we got 6 over 3, divide each by 3, we've got 2 over 1. And then you have 2 times 10 is 20. 20 equals 20. We just verified that this fractional answer is indeed my solution. So your answers can be fractions, just be sure to simplify them. It's much easier than if you were to divide this. Dividing 10 by 3 can take you the rest of your life. We know this is going to be some non-terminating decimal. So just leave it as a fraction, check it, and be done. So now we have a couple of special cases that you're going to work with. So the first special case that we have is when you have a coefficient that is either 1 or a negative 1. And then the second one is we've talked about the law of signs. Now you're going to make it work for you. So with example number 1, your equation is pronounced the opposite of x equals 10. And we kind of know what this answer is, but we have to show our work. We're not solving for the opposite of x. We need to figure out what x is. So you think of this as this coefficient is really a coefficient of negative 1. So how do you separate negative 1 times x? You depot a negative 1. That allows it to cancel here, leaves you with x. X is equal to a 10 divided by a negative 1. That's a negative 10. So plug it in. Here's where you see it. The opposite, my solution is a negative 10. So when I plug it in, I'm going to put it in parentheses. So it looks like this. What's the opposite of a negative 10? Well, 10. So 10 equals 10. This is indeed my solution. The second example is related. I'm not solving for the opposite of x, I'm solving for x. So we know that the law of signs means that I can put my negative anywhere within a fraction and it's equivalent. So why don't we be strategic and put this negative with not the variable? So wherever the variable is, when you have a choice, you send that negative to the bottom. So all I'm going to do is rewrite this as 8 is equal to x over negative 4. Because the law of signs says that these are equivalent. But now when I solve for x, I am in fact solving for x and not its opposite. So when it happens, apply the law of signs to put negative with the non-variable. Okay. So then when we proceed from here, we would impo the negative 4. And I get a negative 4 times 8 is a negative 32 is my answer. So if we are to check this, it's going to look like this. The opposite, I plug in my solution, which is a negative 32 into parentheses. and then I do my math. The opposite of a negative is a positive 32. Positive 32 divided by 4 is 8, so we're good. So the solution to number 2 is x is negative 32. Now we are going to look at a couple of other special cases. Here's an example. Sometimes you will see things that look like this. And when you see it, you think, well, there's two things that are happening to x. It's being multiplied by 5, then it's being divided by 7. So you can do this in 2 steps, or you can rewrite this and work a little bit more strategically. So multiplying by 5 and dividing by 7 is in fact multiplying by the fraction 5/7. So you rewrite this as the coefficient 5/7 is equal to 2. And then I am multiplying x by a fraction. So how do I undo it? I divide by a fraction, but dividing by a fraction is multiplying by its reciprocal. So the easiest way to think about this right now is I'm going to impo the reciprocal, which is 7/5. 7/5. And again, anytime we work with fractions, we want everything to look like a fraction. So here, cancel, 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 cancel. We got x is equal to, see if I can cross simplify. If not, multiply the numerators, multiply the denominators, and my solution will be another rational number. The easiest way to check it, because it's harder to do mentally, is to plug it in. So 5/7 times x, which we are saying is 15/5, should be equal to 2. And this is, again, why we love fractions. It's very easy to multiply. We got a 5 on top, 5 on the bottom, cancel, cancel. 14/7 is really 2/1, so 2, in fact, equals 2. My solution is the fraction 15/5. A couple of tips in addition to that pink sheet, which you should be referencing anytime you've got questions. If you can simplify either side of the equation before you proceed into solving it, you should. So tip number 1 is to simplify both sides of the equation before solving. And there are 8 different rules that have to be met in order for you to say that a side is simplified. So this little sheet, all 8 of these, you have to keep in mind what it takes to be simplified. It's the ordering, it's the combining like terms, it's all of these things. If you simplify both sides first, you can save yourself a lot of work in solving. So for instance, if we have an equation that looks like this, 12 plus x is equal to negative 14, this left side should already look a little weird to you because we have trained ourselves to put the variable terms before the constant terms. So I'm going to apply this first tip. Go ahead and use the commutative property, switch this order around so that the constants are at the end, and then you can go ahead and solve. So I SPO the 12, create that 0, x is equal to negative 14 minus 12, negative 26. Check it mentally. 12 plus negative 26 is negative 14. So here's my solution. Okay. The other tip that I have for you is tip number 2. The unknown must be on top. So your variable must be on top because otherwise nothing is happening to it. It's doing the dividing. For example, if you have something like this, 11 over x is 2, and we ask ourselves what is being done to x, here nothing is being done to x. So you need to make sure that this variable goes on top. So I take the reciprocal of this side, but what I do to one side, I have to do to the other. So if I take the reciprocal of the left, I take the reciprocal of the right also so that these two are balanced. So now it's a regular equation. X is being divided by 11, so I have to impo 11. So x is equal to, try to cross simplify, 11 halves. And if you needed to check it to verify, go ahead and try it. But the answer is 11 halves. Okay. So now we are to our second do now. So for do now number 2, I would like you to put a big old cloud, as Ms. Strickland says, it is a happy cloud, around do now number 2. So your first one, A, is the equation 4/5 is equal to 3 over x. And for the second one, you're going to solve 25 minus x is equal to 16. So go ahead and pause it, and then come back when you're finished. So on A, you have to make sure that you have flipped both sides so that you can get that x on top. So I flip the x over the 3. What I do to one side, I do to the other. So your new equation is now 5/4 equals x over 3. What is happening to x? It's being divided by 3. So I impo 3 to both sides, make it look like a fraction, simplify if you can. If not, your answer is 15 over 5 is equal to x. So again, anytime you have a fractional answer, you might just want to plug it in to verify if you have the time, and you should, especially on quiz days. So on B, we have another issue with B. We have a hidden coefficient on x, which is actually -1, and the thing is out of order. So you train yourself to, anytime there is subtraction, you put a little open top box around that subtraction, and you think of that as now being negative. Minus x is the same thing as adding a negative x. So when I reorder this to get the variables in front, that negative travels with me. So it's -6 plus 25 is equal to 16. So when I solve this, I have to subtract, I SPO 25 to both sides, SPO 25, and I end up with -x is equal to 16 minus 25. Well, that's a -9. And here's an issue that we've dealt with before. I can't solve for the opposite of x, I need x. So what do? I have to depot that -1. So x is equal to a positive 9. Okay? So really you're thinking, well, this is now a two-step equation because I SPO'd and then I depot'd. So the final thing that we're going to talk about today is how to approach two-step equations. If there are two or more things that are happening to your variable, you approach this as reverse gems. You get rid of the thing that isn't attached to x first and then work backwards. So think of it as reverse gems. If you're unpackaging stuff, you're going to get rid of the subtraction and the addition before the multiplication and division, exponents, and then finally the grouping. So think of this as actually, I guess, SMEG. So instead of gems, you're going to do SMEG. So for instance, if I have the equation 4x minus 3 is equal to 9, what's happening to x? It's being multiplied by 4, and it's being lessened by 3. So I am telling you to get rid of the things that aren't attached to x first. So subtraction in SMEG is actually the first thing. So I undo subtraction by adding 3. I apo 3, leaves me with 4x is equal to 12, and then I depot 4. So my answer is 3. Do a quick mental check. 4 times 3 is 12, minus 3 is 9. The second example we're going to look at is -2 plus x over 5 is equal to 4. So again, we want all of our variable terms in the front. So I'm going to use that commutative property to switch it so it's in standard form. Makes it x over 5 minus 2. Whatever's right in front of that constant is the sign of it. If there's nothing in front of it, it's positive. So this is equivalent to what you see here. So anything not attached to x, I'm going to get rid of first. So I apo 2 leaves me x over 5 is equal to 6. And then I mpo 5. These cancel out. X is equal to 30. And again, give it another check. 30 over 5 is 6. 6 plus a -2 is 4. So my solution is 30. The last one we're going to look at today is -3x over 7 plus 4 is equal to 22. So again, here's an issue where we want, if we can work in one step versus two, we're going to do it. So I'm going to rewrite this as x has a coefficient of -3/7. And the law of sign says I always put that negative with the numerator. So now I'm going to SPO the 4. And I kind of ran out of room, so I'm going to transfer it. What's left on the right side is this. and 22 minus 4 was 18. So now how do I separate the coefficient from the x? Well, I divide, but the fastest way to do this is to multiply by the reciprocal. So again, I'm still going to keep that negative on the top. So we've got essentially a -1, a -1, negative times negative, that's a positive. So I multiply by that reciprocal here, make it look like a fraction. Oh, 18 over 3 is really 6 over 1. And then 6 times a -7, I think the solution is -42. So if you plug it in, -3 times -42 is a positive. If you divide that by 7 and then add 4, you're going to get 22. So be sure that you at least mentally check these before you claim it's your solution. My recommendation is if your solution is not a whole number, go ahead and substitute it in to verify.